Welcome to our online webinar. Hello, welcome to our online webinar. I'm Jacob Biedulski. We are Control Byte and we teach industrial automation and PLC programming. Nice to see you all. Remember that today we have a live session. It means that we can discuss your questions. Okay, maybe let's start with a simple question. Write on the chat, where do you come from and what do you want to learn from us? Okay. This is live session, so we will answer all your questions on the chat. Today we have a very interesting topic, which is analog signals for industrial automation. We will compare voltage and current loops. We'll look into schematics so that you can get knowledge how to connect each sensors. Okay, we have first viewer. I'm from Nigeria. Hello, Goody. Nice to see you. Okay, before we start, remember to hit the like button. Maybe this view. Remember to hit the like button and subscribe to Control Byte YouTube channel so you will be up to date with our live streams and our videos. Okay, Goody says, hi, I'm from Nigeria and I want to learn about analog signals. So you are in a perfect place, Goody. Nice to see you. Okay, Hale from Latvia. Nice to see you, Hale. So if you have joined right now, remember, write on the chat, where do you come from and what do you want to learn? And we start with our presentation in a minute. Before I will send I will send you a link to our website for those who are new to our e-learning platform and our courses. We are Control Byte and we teach PLC programming and industrial automation. We have different learning programs for PLC programming and for HMI and SCADA programming as well. And today we discuss topics related to industrial automation basics and electrical diagrams. Okay. So if you want to learn and get job in industrial automation, check out our website. And that's it. So let's start with our topic. Okay, we have hello from Tanzania. I want to learn about automation system design. Okay, perfect. You're in the right place. Courage. I'm from South Africa. I want to learn about PLC programming. Okay, so this is a perfect channel you as well. Given says, I'm into robotics. I want to learn more about programming. As you know, we have live sessions. We have lessons about PLC programming and the basics of instrumentation as well. Today, we'll discuss analog signals. I will show you what is the difference between current loop and voltage signals. So let's start with a simple task. Let's assume that your boss told you to select analog pressure sensor for your machine, for the pneumatic system, okay? So the first step, you open a catalog with the sensors, for example, from TARC company. And this is our partner. We cooperate with TARC, so you can find some materials from them on our website as well. But if you go to a catalog, you will see more than 300 different sensors with different signals. Let's go to electrical output parameter. And here you will find option for current output 2-wire, current output 3-wire, or voltage output 3-wire. So those are the three most common analog signals for the sensors. And we will discuss each of them during this short presentation, okay? So firstly, let's check how we can connect such a sensor to a PLC system. Here on the slide, you can see SM1231 analog module for S7-1200 Siemens PLC. There are different types for this module, and there are three types: 4-channel, 8-channel, and 4-channel 16-bit. So they differ in resolution. The basic ones are with 13-bit resolution. The more advanced one is 16-bit. So this is more accurate module. And if you go lower, you will see that this module can measure different signal types: plus minus 10 volts, plus minus 5 volts, 0 to 20 milliamps, and 4 to 20 milliamps. So you can configure this module to measure current loop or voltage signal, okay? And every automation engineer or specialist technician starts with the CPU unit. The analog module is expensive, but the CPU is equipped with two analog inputs. Those inputs are voltage inputs with a scale from 0 to 10 volts, but they have only 10-bit resolution. So this resolution is really poor, but it is okay, for example, to connect a potentiometer and measure the basic signal, okay? So what is also important about the analog modules is the type, okay? Here you have voltage signal, but it is described as single-ended. It means that all the channels have the common ground connection, okay? The first channel and the second have the common ground connection. We have a question from Akmal. Are you a Russian speaker? No, we are from Poland, Central Europe. So we are not Russians, if you ask about this. Okay, we have new viewers on a live stream. Hello, Adrian. Nice to see you. Okay, we have also Zoltan from Serbia. Nice to see you, Zoltan. Adrian wants to learn about different signal types. Okay, so we'll discuss them during this meeting. Okay, let's go back to our presentation. So here we have voltage single-ended. It means that those two channels are connected to the common ground, okay? And if you go to the advanced module, this module is equipped with differential signal, okay? We can connect differential signal to this module. This will be important information for us in a minute. So today we discuss modules from S7 1200 G1, and right now you can also buy S7 1200 G2. It will be available on our channel in a short time, because right now not all the modules are available. Not all the modules you can buy. So we'll introduce this newer generation in a short time on our YouTube channel, for sure. Okay, so let's go back to our S7 1200. Here you have SM analog module. And if you go to configuration, you can see that you can configure the module as well as the voltage signal and the current signal. So you can connect the sensor with voltage output or current output as well. So let's start with the voltage signal, the voltage sensor. This is a sensor with simpler implementation, easy connection and configuration, low cost. The electronics for the sensor is cheaper compared to 4 to 20 milliamps. You have direct relationship. Voltage is directly proportional to the measured value, 0, 10 volts. It is commonly used, widely applied in BMS systems and simple machines. And what is really important, you can connect a potentiometer to this voltage input and measure the rotation of the potentiometer. And it is really easy in diagnostics. The voltage can be measured with a standard multimeter. You just set the multimeter to voltage measurement. You connect to the circuit, and that's it. It's harder to measure the current loop. I will show you this in a minute. Okay, we have Zoltan from Slovakia. Nice to see you. Khalid from Sweden. Hello, Khalid. Nice to see you. What are disadvantages of the 0 to 10 volts signal? So 0 to 10 volts signal is worse than current loop because it can be interfered by the electromagnetic fields in your machine, especially when it comes to long cables, okay? The second thing is that there will be a voltage drops on a long signal transmission paths when you apply long cables or connectors. This can cause voltage drops in your signal. You cannot detect circuit break. 0 volt can indicate either no signal or a minimum value signal. And for current loop, there is a standard where the signal, the proper signal starts with 4 milliamps, okay? And if the current is lower than 4 milliamps, it means an error. There is no such a thing in a standard 0 to 10 volts signal. Voltage signal has also lower noise immunity compared to current transmission. So to sum up, the 0 to 10 volt signal is ideal for local, non-critical applications where simplicity and low cost are priorities. In industrial applications of a greater importance or in environments with a high level of electromagnetic interference, the 4 to 20 milliamp signal will be a better choice. Okay, so there are more than 40 viewers right on this live stream. And wait a minute. So now please hit the like button and subscribe to our channel. If I will see more than, I think, 30 likes under this video, we'll continue the presentation. Okay, so I'm waiting for the 30 likes and we'll continue the presentation. If you have hit the like, you can confirm it on the chat, and I will be sure that you have subscribed and hit the like button. Okay, let's check how many likes there are under this video. Okay, 22, 25 right now. So 5 more and we'll continue with the wiring diagrams. Today, our topic is how to read electrical diagrams for industrial automation regarding analog signals. I will show you the basic schemes related to 0 to 10 volt signals and the current loops 4 to 20 milliamps. Okay, 2 more likes and we continue the presentation. Okay, so Vladimir sends likes. Superb, thank you. Liked already. Okay, nice. So let's continue. Let's start with free wire connection of 0 to 10 volt sensor. Here on the right, you can see a sample sensor. This is the pressure sensor that we have selected from TARC catalog. And this is a piece of documentation that you will see in almost every standard industrial sensor. So you will see the features and the wiring diagrams. When the sensor comes with a connector, you can also see the pinout of the plug or the socket, okay? So such a free wire sensor, the sensor with free wire connection has 3 cables, 3 wires, okay? The first one, L plus, is, maybe I will switch on the drawing application. Wait a minute. Okay. And let's draw on the schematics. Okay, let's test. Perfect. Okay. So here is the schematics from the manufacturer. The first connection is the L plus. This is plus 24 volts potential, okay? And it comes from the DC power supply, okay? As you can see, the Siemens module has the same power supply as the sensor, okay? So we power from the same SMPS, the module L plus M, and the sensor. This is L plus connection to the sensor, plus 24 volts, okay? And the second connection, L minus, this is 0 volts potential, and it goes to L minus or 3. If you look into the plug, the third pin would be L minus. This is 0 volts, okay? And we have 2 wires that go to analog module, okay, to analog channel. So here we have the analog channel of number 0. They are numbered from 0 to 3 for this module. So this is the channel of number 0, and this is the channel of number 1, okay? We have to connect 2 wires to this module to 0 minus and 0 plus. 0 minus, this is the reference potential for the analog signal. We have 0 to 10 volts sensor, so it gives on the output the potential according to the common ground, okay? So here we connect the first wire. This is the reference potential for this channel, 0 volts, and this is the same potential as the minus on the SMPS, okay? So the second signal, the second wire, is the voltage signal that is the output of the sensor, and this is from 0 to 10 volts. Oh, sorry. From 0 to 10 volts signal. Okay. Perfect. If you look at the schematics right here, you will see that there are 4 wires or 4 pins. They are designated with 1, 3, 2, 4. So the first pin, the first wire, is the plus 24 volts power supply, and this wire is this wire is generally brown, okay? So the second wire is designated as 3. This is 0 volts wire, and this wire is blue. The output signal, the analog output signal, is the wire with designation 2, and this will be white, and the last is black, okay? So this is standard, those are standard colors for almost every sensor. Okay, so let's move to the next slide. Okay, as you can see on this schematic on the left, if we connect a 3-wire sensor to an analog module, there will be 2 loops. The first, sorry, the first circuit on the left is the power circuit for the sensor. So here we power the sensor's electronics. This is this part. And the second loop, the second circuit, is the signal circuit. And the signal circuit on the schematics is right here, okay? And what is important about this this diagram is that the power circuit and the signal circuit have the common ground, okay? It means that if you connect the signal circuit and the power circuit with the common ground, and you have, for example, some inductive loads connected to this DC power supply, it will cause some interference in the signal circuit as well. So if you power your analog module, you have to consider to use separate SMPS 24 volts power supply. Otherwise, you can see some disturbances on this signal side. Okay, let's sum up. If we want to wire 0 to 10 volts signal with a 3-wire connection, the sensor shares a common ground for power supply and output signal. There are 3 wires plus 24 volts. This is power supply, ground, and analog signal 0 to 10 volts. The connection as follows: 24 volts DC to terminal L plus of the module, ground to M, signal to 0 plus or 1 plus. It refers to the analog channel, okay? And of course 0 minus to M as well, to the ground. So you have to pay attention about the fact that the sensor is not galvanically isolated from the power supply. Now let's discuss 4-wire connection of a 0 to 10 volts sensor. So here is the schematics for this configuration. The sensor has isolated grounds for power supply and output signal. There are 4 wires, 24 volts DC, ground for power section, output signal 0 to 10 volts, and signal ground. The signal has its own grounding wire, okay? And as you can see, there is no bridge between the DC minus negative pole and the minus wire that is connected to the analog channel. What are advantages of such a connection? There is separation of signal and power ground. This will cause better noise immunity. The sensor is electrically independent from the input module. The measurement will be more stable. But as you can remember, in industrial practice, we use mainly 3-wire connection because it is easier to implement, and 4-wire connection is more expensive when it comes to transducer and electronics. So if we go to, for example, Turk catalog, there will be no such a sensor regarding voltage signal. The standard signals are mainly 3-wire connections. You have to be careful because on the in Siemens documentation on the Siemens website, you can also find a mix of 3-wire and 4-wire connection. Sometimes the sensors have separate minus wire, and to have stable measurement, you have to connect this wire also to the DC minus pole to the M connection of the sensor, okay? So it depends on the scenario, it depends on the application that you use the sensor. What are the problems of voltage signals? So in systems where the analog signal is transmitted as a voltage, even small voltage drops on wires or connectors can distort the measurement result. This happens because every wire has its own resistance expressed in ohms per meter. Connectors, plugs, and contacts may have contact resistance, especially over time, oxidation, looseness, humidity, and so on. So when current flows through such a path, for example, PLC analog input load, a voltage drop occurs according to Ohm's law. For example, you have signals from the sensors, 0 to 10 volts. Let's assume it's, for example, 10 volts. And on this measurement path, you have some wires, some connectors, and the voltage measured on the analog module will be 9.95 because of the voltage drop. Okay, so how can we prevent it? We can use adequate cross sections of the wires, 0.5 to 0.75 square millimeters. Use good quality connectors with gold plating, and minimize wire length in analog applications. If we have longer distances, we have to switch to current loops, to current signals, okay? Here is a calculation of sample voltage drops for voltage signal when it comes to 100 meter cable with cross section of 0.34 square millimeters. And you can see that this cable causes 1.3 millivolts of drop. The same with the connector that can also cause a voltage drop, okay? So with analog signals, we have some problems regarding EMC disturbances, pulses from motors, relays, inverters, and so on. There can also be higher interference from long parallel power cables, especially when it comes to lack of shielding on signal wires. We can also see problems when it comes to ground loops and potential differences. So how can we prevent it? We can use shielded cables. We can avoid routing signals parallel to power lines, apply software filters, and for critical applications, we prefer to use 4 to 20 milliamp signals. Okay, so what? Sorry. What are possible wires that we can use in our signal paths? Here on the right, you can see 3 types of wires. The first on the right, this is the non-shielded cable, LIYY, from lab cable. This is a special cable dedicated for analog signals with no high frequencies. We usually use cables with cross sections 0.5 to 0.75 square millimeters. The best option is to use shielded cables. This is the one on the left. This is the LIYCY. The C means that this cable is shielded, and the shielding will prevent interferences in our system. As you can see, the standard cable consists of multiple cores, and they are twisted around the central core, the central of the cable. For more critical applications, we can use a better cable, which is the one in the middle, LIYCY TP. What does TP means? This means twisted pair. So this wire consists of two twisted pairs of the cores, and this causes the best noise immunity of all those wires. And you should remember that if you use signal cables, you should connect the shielding to PE, protective earth, only on the one side of the cable, the PLC side, not to cause ground loops. You should also route the cable far from power cables. Use special signal ducts, which are grounded as well, and do not connect the shield to the ground of the PLC. Connect to this shield to PE, protective earth. Okay, so you know some information about the voltage signal. Now let's move to current loops. So there are advantages of the current loop that causes this signal is used in more than 80 or even 90% of applications in industrial automation. Current loops, current signals are the best when it comes to noisy environment. It is stable over long cables. There is minimal impact of cable length on measurement accuracy. You can easily detect the fault or break in the cable. The sensor can be directly supplied from the same loop. You can use two-wire sensors. It is impossible when it comes to voltage signals. This is industrial standard, and as I said, has higher reliability in environments with high EMC levels. What are disadvantages of 4 to 20 milliamp signals? Those signals causes the electronics a little more expensive. You also need a measurement resistor in the electronics. Sometimes it is already built in the analog signal. Sometimes you have to add one. More difficult testing, you have to get a special multimeter to measure the current loop. Less intuitive, voltage is more readable for beginner and easier to troubleshoot. But as I said, 80 or even 90% of industrial applications are the current loop signals. What are the possible connection of the sensors which have current loop signal? We use the same module, SM1231 module from Siemens. Here on the left, you can see two-wire connection, and here on the right, four-wire connection. So let's discuss those two connections. If we go to a sample sensor, to a catalog or a manual, you can see such a view. This is the photo or of the sensor, and right on here on the right, you can see the wiring diagram. So here on the diagram, you have a brown wire and white wire, the plus and the minus. The plus is the power supply for the sensor, and the minus is the current loop signal that we connect to the proper terminal block on the analog module, okay? So let's check how we can connect such a sensor to our Siemens module. Here we have 24 volts power supply. We have to connect it to L plus and M of the Siemens module as well. And to the brown wire designated with 1, we connect plus 24 volts power supply, okay? This is two-wire sensor, so the second connection provides the signal to the input channel. So the second connection is designated with minus. Not always you have to connect plus to plus, minus to minus. Sometimes you have to connect, for example, minus to plus. So how can you know how to connect such a sensor? The best way is to draw how the current flows in this circuit. We start with L plus, okay? So the current flows right here to the connection with the plus of the sensor. Then it goes from plus to minus. And if you don't know to which terminal you should connect the minus or the plus, okay, you should consider how the current will flow inside the analog module. So in the analog module, the current flow from plus to minus. So inside the current flows right like this, okay? So you have the path in the sensor from plus to minus, and if you know the current flow direction in the analog module, so you will know that the current should flow to 0 plus terminal, okay? We have many questions regarding the connection of two-wire sensor. This is a common mistake that someone connects the plus to plus and minus to minus, okay? So the best way is to check the manufacturer documentation right here. Here you have also a symbol of the output load. Right here, this is some kind of resistance, and this symbol refers to the analog module, the inside electronics. Okay, let's check how many likes there are under this video. There are more than 45 viewers right now. Superb, perfect. And there are only 35 likes. So let's hit the like button under this video and we'll continue with our slides. Okay, I'm waiting for the likes and we'll continue with the presentation. Okay, so how many likes there are under the video? There are 40 likes. Okay, so let's move on with the presentation with our topic, analog signals. Okay, the last important topic about the two-wire connection is the circuit. Here you can see a really small a circuit of this two-wire connection, and I don't know if I can enlarge this. I think I'm not able, but you should see that here we have power supply, the transmitter, the receiver, which is the analog module, and the this circuit has also common grounding point. Okay, so in two-wire connection, there will be also some interference between the power supply signal, the power supply voltage, the quality of the voltage for power supply section, and the sensor. Okay, now let's discuss four-wire connection. So here we have power supply, our transducer, and let's start with L+. So we have maybe better with the red one, okay. So here we have L+ for the sensor, this is power supply, L- or M, okay. And we have two wires as the output of the sensor. Sometimes there are not four wires, there will be three wires, okay? For our pressure sensor, there are, for example, only three-wire connection possible, but sometimes there are four wires. So the output of the sensor has differential signal that we connect to our analog module, okay? And the best part of such a connection is that there are two separate circuits for the power supply of the sensor and the separate circuit for the signal path, okay? And with this connection type, you get the best immunity for the measurement system. Okay, we have question. Can we watch later this live stream? I think that it will be available maybe a few days, and then we'll see. Okay, Hale says already liked and liked in here too. Thank you, Hale. We have like from Vladimir. Nice to hear that. Okay. So we have almost 48 minutes of the live stream, so we'll be summarizing our topic right now, and I have some special information for the viewers and special bonuses, okay? So in the previous slides, you saw how to connect SM1231 modules of the S7-1200 PLC. If you want to use advanced measurements, you can use, for example, ET200 system. This is the centralized I/O systems for Siemens PLCs. And you can use there, for example, high feature modules. Those modules have different connection possibilities for the sensors. For the S7-1200 modules, to power the sensors, we had to use the same power supply as the power supply for the module. So we took the potential from the SMPS that is powering the whole module, okay? The ET200SP system has more connections, and here you can see the terminal blocks for these systems. Here on the right, you can see the connection of current loop to this system. And what is the best part of this system is that you have dedicated terminals for powering the sensor and dedicated terminals for the signal wires, okay? So inside the module, there is power supply for the sensor that is filtered and maintained by the system. Okay, so I will switch the presentation right now. I can see that there are more than 40 viewers right now. Thank you for your attention. And now I have some special bonus for you. I see that you are really into automation and robotics. You want to learn much. And wait a minute. Okay. So on our YouTube channel, you can find many interesting webinars, videos with our partners about industrial automation basics and PLC programming. But on our platform, we have also full training programs for aspiring automation specialists, technicians, engineers, and many more, and so on. So on our platform, you can learn PLC programming, especially Siemens PLCs, and in the future, Allen Bradley Rockwell as well. We have industrial automation basics course, how to read electrical diagrams, and many more. If you want to work as automation specialist, you can ask yourself, what do I need to know? Can ask, is this robotics? As far as I know, it is not. We have also modules in CodeSys course, which relates to robotics, where we teach different kinematics of manipulators and many more. We have also servo drive course, where you learn how to program trajectories and many more. So we also have a lot of materials about the robotics as well. Okay, if you want to learn industrial automation, you can ask yourself, what do you need to know? Here you can see, for example, a pallet wrapper machine. On the right, there's a control cabinet of such a pallet wrapper. On the left, you can see all the mechanism and the control cabinet next to it. So this is example how such a pallet wrapping machine works. This is a conveyor system for such a pallet wrapper and the wrapping module in action. Okay. So right now you can sit back in your chair and see how the automation system works based on 3D model and a simulation. We have prepared a full course on industrial automation basics based on the most important standards for automation manufacturers, which is IEC 60204 Part 1. This is the standard that will tell you how the machine system should work. And the second standard will tell you how the control cabinet should be constructed, okay? In our course, we have made a full case study learning on based on 3D model of a control cabinet, okay? I will show you in a minute our website. Right now, we have opened registration for Industrial Automation Basics course. This is the course. There are 2 days left to sign up. If you, okay, I will send you a link on the chat. If you want to start your job in automation and robotics, this is the perfect option to learn. We base on a 3D model of a control cabinet and a pallet wrapping station. And your task will be to design an electrical control panel that will include drive control systems, PLC for reading digital and analog signals, HMI panel and buttons system implementing safety functions. So in our course, we'll provide 2D schematics and 3D model of the control cabinet, so you can refer the symbols in the diagram to the real-world devices in the 3D model. You can easily track the potential in the 3D model and refer to the sheets of the 2D schematics. Is it lifetime access course? Yeah, right now we have a lifetime access for our courses, but I think that in this year we'll change the policy. So if you enroll into the PLC course or Industrial Automation Basics course, which is available right now, this course is available right now, you will get lifetime access. This is Industrial Automation Basics course and how to read electrical schematics training, okay? In this course, we'll provide schematics for the pallet wrapping machine and the 3D model of such a control cabinet. So what will you get when you sign up for the course? You will get learning materials, more than 50 video lessons explaining the basics of industrial automation design. As I said, lifetime access to materials on the e-learning platform. You'll also get consultations, and you will get contact to the instructors, to me and Matthew. On our Discord chat, we provide help for the students there. You will get in touch with us via e-learning platform and Discord. Of course, the best part is homework to do. During this course, you will have lots of homework assignments and a proven educational path by hundreds of students. We work with our students since 2019, so this is more than 5 years now. We teach PLC programming and the basics of industrial automation and the basics of electrical diagrams. Bruno asks, which software will be accessible to work with? I will show you this in a minute. You will get more than 50 video lessons explaining in detail the topics of industrial automation. This is one of the lessons. We base on a 3D model of the control cabinet. Here you have, for example, power supply section, terminal blocks for connecting power to a machine. We explain the cable, the colors of the cables, the meanings of the designations, and what is the best part, you can refer this 3D model to 2D schematics. So step by step, we follow all the devices, all the pages of this schematics, and we analyze the 3D model. You can feel just like in a real factory on a job as an automation specialist. Can ask, the different company modules have different features among each other. The coding is also different. How can this issue covered for one individual? So, as I said, we base on European standards, IEC. There are two standards, the main standards that we based on, and we explain the automation systems according to those standards. If you want to buy those standards, you will spend like 600 euros. And if you buy the course, the standards will be covered in this course, okay? And you are right, there are different standards for different world regions. For example, there are different schematics for Japanese machines, for European, and so on. If you have questions regarding your cases, your schematics, you can reach out to us on our Discord. Okay, I will show you our Discord chat. This is our Discord channel, and we have, for example, forum where our students ask questions. They also show their work here. And if you have questions regarding some standards, regarding some schematics of your own, you can ask there with no problem. So in our Industrial Automation Basics course, we start with introduction to the project. Here you can find description of an industrial machine, which is a pallet wrapper, description of the control cabinet based on a 3D model, and automation devices that you will use in this course. We'll talk also about design assumptions and list of electric drives. The next module will be selection of electrical protections. We'll talk about connecting the machine to the power supply at the customer's industrial plant. We will select the power disconnection device, the protection of the power supply cable, and we'll talk about colors of the cables used in industrial automation based on standards. The next module, the basic elements in the control cabinet, which are electrical terminal blocks, service sockets, cabinet temperature control devices like fans, heaters, overcurrent circuit breakers and fuses, and disconnectors and circuit breakers. The next module, electric drives, will give you a brief introduction into induction motors, three-phase motors, how they work, how you connect such a motor. We'll talk about motor protection devices, contactors, different startup methods like direct, soft start, inverters, and servo drives. Okay, and the next module will be PLC systems in control cabinet. You will learn how to power supply such a PLC in the control circuits. We'll select 24 volts power supply, SMPS. You will connect the PLC to the power supply. and we'll talk about the PLC on the electrical diagram, how it is presented. We'll dive deep into input and outputs connections. Today we talked about a little about the analog signals. In the course, we starts from the scratch, so we'll talk about digital input modules, digital output modules of different types, sync source, and we'll talk about PLC output protection circuits that protect from short circuits and overloads. Okay. In the course, you will learn how to connect input and output devices to the PLC. Those devices in the course, you will find like buttons, switches, different sensors like PNP and PN types. You will connect PLC and an inverter. You'll connect different analog signals, relays to the outputs, and the electronic valves. Okay, I have question. Hale asks, how can I protect the PLC if the analog device is damaged and possesses a risk, including potential damage to the PLC? So if you connect analog signal, this is regarding our topic, I hope. So if you connect an analog signal that has a different grounding potential than the PLC, you can use a special filter or a separate device, a separating device. Wait a minute. So regarding your question, this is galvanically separating device from Phoenix contact. You can copy and paste this in Google to your consideration. So you connect a signal of, for example, 4 to 20 milliamps, and the output is also 4 to 20 milliamps, but they are galvanically isolated. Okay, so let's go back to our presentation. If you want to join our industrial automation basics course, this is the right time to make up your mind. We have 2 days to close the registration, and in our course you will learn how to connect different devices to PLC system. Okay. You will connect buttons, switches, different types of sensors, and VFD, an inverter, relays, valves, and so on. We have also a module related to machine safety. We created this module with Wieland Electric. This is a company that specializes in safety devices for industrial applications. So this module has topics related to safety requirements, risk analysis, example of emergency stop with a safety switch, safety barriers, and many more. So if you join our course, you need only your computer with internet access to start learning and designing your own control cabinet. In this course, you will use free tools, and we will show you how to install and use the browser tools like Wago Smart Designer, TIA Portal Selection Tool, Retail Configuration for control panels, LYCY Drive Selection Tool for selecting drives, electrical schematics. We'll deliver those PDF files in the course, and you will also get 3D model of the industrial machine that is ready to go, ready made. So this is, for example, WAGO Smart Designer. This is a special tool for creating terminal blocks. You can create such a block in 3D. You can also add a PLC system here, input and output modules. We'll also use TIA Portal Selection Tool. This is a tool for configuring your PLC system. And in our course, your task will be to select proper modules for our application. We'll use S7-1200 PLC system, and according to our schematics, according to our project assumptions, you will have to create a bill of materials for your PLC system. We'll also use Retail Configurator for control panels, for control cabinets. You will learn how this control cabinet is built from scratch, what is the structure, what are the parts of such a cabinet, how to order the cabinet to fit into your application. Okay, quick question for you. How much does Industrial Automation Designer can earn per month? The answer is no limit. It depends on your hard work and determination. So to get a job in automation and robotics, you have to gain some essential skills to start your job. You have to know how the control cabinets work, how to troubleshoot, how the devices in this control cabinet operates, and so on. You have to also know how to read electrical diagrams that are created in the CAD software like ePlan, SolidWorks Electrical, and so on. You also have to gain knowledge about the standards for industrial machines, for industrial control systems. You have to get the basics of safety systems for machines. And you have to know how to use web configurators from automation manufacturers, how to use catalogs, manuals, and so on. In our course, we'll also make an introduction into drive applications. You will learn how to select different types of drives, VFDs, for different applications like pumping, moving, processing, and machining. This is an example of wires that we'll use in the project of different classes. And you will learn how to connect a control cabinet to a power supply on your client's factory, on your client's plant. We'll also give you introduction into colors of wires in the control cabinet. There is a standard that says which wire of which functions has designated color. We'll talk also about PLC networks. And as I said, drive systems will show you how to select starting methods for different applications in your project. You will select an enclosure for the project, for the pallet wrapping machine, and you will learn how which measurements in low voltage switchgear are required regarding to LIYC standard. Yeah, this is the measurement of the switchgear. And as I said, if you want to learn about different devices in the control cabinet, we have a special training for you. This is Industrial Automation Basics training, where you learn about the instrumentation and how to read electrical diagrams. Okay. In the course, you will learn how to power your PLC, how to select power supply system for your control circuits. We'll talk about different types of SMPS. I will show you how to select the proper one for your application. We'll talk about different types of protections of 24 volts circuits. The electronic protections, the fuses, circuit breakers, the differences. You will learn all of about that in our training. You will also learn how to connect different devices to the PLCs. You will also learn how the electronics inside the PLC is constructed, why the PLC works in that way and another. You will see how to connect the sensors in the 3D model and the 2D schematics. As you can see, we work simultaneously with the 3D model and the schematics. We explain all the connections from the schematics. In the 3D model, you can track every wire, you can track the potential, you can check all the designations in the devices and the terminal blocks. Okay, so we have an industrial automation basics course for you, over 50 practical video lessons, support from instructors via Discord, our chat, a certificate of completion in English of this course, and we have a satisfaction guarantee. We have 14-day refund policy. There is 100% secure of the transaction. The best part, homework task to complete on your own, and you will get a review of your homework task and your code from the instructors. A certificate of course completion that you can share on LinkedIn. We have a special mechanism right now. You can publish the certificate on your LinkedIn page, and it is linked to our website. The first bonus, the Discord chat. This is our meeting place, the course support for our students. If you have any problems, you can reach out to us. The second bonus is electrical schematics guide. This is a PDF with all the essential informations gathered with all the symbols that you will use in electrical schematics during the course. This is a PDF with more than 30 or 40 pages right now, and have it on your desk, and you can always take a look if you have any doubts about the symbols that you can see in the 2D schematics in the documentation. So during our course, you will learn how to read electrical schematics from the scratch. You will learn how the electrical schematics are designed, what are the main parts, what are the functions, locations, and so on. You will learn about the terminal blocks, and all the tasks and all the projects will be based on the documentation that we deliver with the course. For whom? This course is for people who want to create projects, upgrade installations, provide maintenance, and manage projects in industrial automation industry. When we created this course, we asked future automation engineers what challenges do they face. Some students says, I don't have access to the right expensive automation equipment. So we advise you to start by learning the basics of automation with the 3D model of a control cabinet. We deliver PDF files of the electrical schematics and we'll show you free tools from manufacturers. A question from Khan. Which company do you follow, Siemens, Schneider, or any others? So we base our courses on Siemens because this is the most popular PLC in the world, in my opinion. Some people say, I have never dealt with project and don't know how to start. So we suggest to learn the basics first with a real project. 3D model of a control cabinet, the standards, the manufacturer documentation, and exercises with specialists. Some people say, I'm overwhelmed by the amount of knowledge to acquire. In our course, we explain the concepts from the basics to complex. Some people have lack of motivation. Don't worry, we have a Discord group, will help you to stay motivated. I'm Jacob, and with my partner Matthew, we run e-learning platform for automation and specialists and PLC programmers. If you would like to carry out industrial projects on your own, you will have tasks to solve on your own in our course. You receive tips from us if you have any problems. Then you can use this knowledge in real projects. We have a question from Lara. If we have a course in English or if it is accessible in French. Right now we have this course in English. I will send you our mail, contact@controlbyte.tech. If you want our course in different language option, in the future we plan to implement other languages. Feel free to reach out to us on our with our mail, contact@controlbyte.tech, and you can ask questions about different language options. Okay, if you don't have time for the PLC and automation training, on our platform, you have access to e-learning materials and to our platform 24/7 from a computer with internet access. How long does the training take? The training takes from 1 to 2 weeks, but you can spread your activity even over the whole year. There is no time limit. We provide support on our Discord channel day by day, 5 days a week, no problems. Access is not expensive. It won't be 5,000 euros. And right now we have special offer for you. We have opened a registration for a training group for 50 future industrial automation specialists. The offer is time limited. There are only 2 days left. The first day is the last day to enroll. Then we close the registration and there will be no possibility to join. What is really important, we have safe transaction and 14-day money back guarantee, okay? We use Stripe, a really safe payment gate, and you just have risk-free enrollment. You can check the course. You have 14 days to get it back. No, we'll just make a full refund with no questions. The refunds occur really not really often. We have no problem with that. Okay, so right now I will send you a link to our webpage. You have some time to check our website. And in a minute, I will show you how to join, okay? So this is the link to our website, to our Industrial Automation Basics course. You can click on the link and go to our web page to check the enrollment process and check all the information about the course. Okay, so let's go to our web page. This is our Industrial Automation Basics course web page. Right here, you can check all the information about the course, the outline of the course, all the modules are listed right here. You can also find sample lessons. You can check the sample lessons on this web page. The bonuses that you will get after signing up for the course. And right now I will show you how to join. So just click the big green button by this course. And here you will see a web page with our special offer. Sometimes we have special offers for course bundles. The standard price for the Industrial Automation Basics course is 189 euros. Right now we have a huge discount. You can join with a price of 97 euros. But let's check out what is here. Here you can select a course bundle, which is also really good offer. You can enroll into Industrial Automation Basics course in a bundle with PLC programming course. This PLC course is our best seller. So every automation specialist starts with Industrial Automation Basics course and this PLC course, programming in ladder logic and FBD. So if you want to start your job in automation and robotics, this is the best option for you to start with PLC programming and Industrial Automation Basics. And if you want to become a specialist, we have all courses bundle. There are 6 courses right now, and there is more than 50% discount for this bundle. This bundle includes the Industrial Automation Basics course, the PLC programming for Siemens PLCs, HMI and SCADA, communication training for Modbus, Profinet, OPC UA, and more protocols, text-based programming for Siemens PLCs, programming in SCL, and servo drives and VFD's motion programming course. So this is PLC programmer and automation specialist bootcamp. So if you want to get a job in automation, this is the best option to start, okay? If you want to buy a bundle, you have to select the all courses bundle, this bundle, or the smallest one, and just click add to cart. You'll be redirected to our Stripe payment gate. This is secure payment gate that is available worldwide. And here you have the courses that you have selected. You can also add, I can see a special offer right here. This is a basic PLC structured text programming course. You can add this course in extra price for, which is 50 euros. Yeah. So let's add this course. And here you have to insert your email address, select payment method, which can be a credit card, PayPal, or different payment gates that are available in your country, okay? If you want to pay in, for example, dollars, there's also such an option. Right here on the left, you can switch the currency if you're if the currency in, sorry in your location is available in Stripe payment gate, it will be highlighted right here. Okay, so here you select payment method, just click pay and finish the payment process. After this, you will get all the information on your email address regarding access to our e-learning platform, the learning materials, contact to us, the instructors, and we'll guide you with all the process, how to start the training. Okay, that's it. Thank you for our online session today. If you want to join Industrial Automation Basics course, I will send you a link on the chat one more time, and we'll be finishing in the minute. So right now we are waiting for a group of 50 future automation specialists who want to start their job in industrial automation. Thank you for watching and see you in the course. Okay, last question. Hale asks, okay, if I have long distance, even for current analog input between the equipment and the main PLC, should I convert this analog input to digital and then over Profinet and then back to analog? So you should know, if you use current loop, you can send this signal, transmit this signal for hundreds of meters with no problems. So current loops are used with 300 meters cables. This is a normal way of transmitting the analog signals. If you have many signals, like for example 10, 20, 30 analog signals, you can use, for example, ET200SP IO module, which I showed today, and then you can send this signal with a Profinet network. Okay, last question from Khalid. I have Dell Core i3 laptop. Is it okay to use in PLC? So Khalid, please write to contact@controlbyte.tech and we'll send you our materials about selecting computer PC for PLC programming. We have such a materials and we'll send you this on your mailbox, okay? So if you have more questions, feel free to contact us with our email, contact@controlbyte.tech. Okay, the email is correct. I thought that there was a typo. No, okay, there is a typo. One more time. Contact control byte dot tech. Okay, this is the correct one. Okay, that's all for today. Thank you for watching, and see you on our PLC and Industrial Automation Basics training. Bye.